Transmission Control Protocol, TCP, for Network Systems ITD 1223 on April 15th, 2020, presented by TaylorPitts. The definition of TCP is Transmission Control Protocol. It is how a conversation on a network not only is established, but how it is also maintained. Through this conversation is where application programs can exchange their data. TCP works together with Internet protocols, better known as IPs, because it is what determines how packets of data will be transferred between computers. TCP and IP are what make up the basic structuring rules that the Internet is actually defined by. TCP is a very crucial functionality of the Internet. The Internet Engineering Task Force, the IETF, even talks about it in one of their standards documents. This is how it works. The figure on the right shows the connection establishment by the three arrows. In the world of technology, this process is commonly referred to as the three-way handshake. The client establishes an initial connection to the server. However, the server must first connect to a port to make it open and available for connections. The process of a server attaching to a port and opening up the pathways is very important. It is referred to as ACK or ACK, which can be seen in the figure. Then, to complete this three-way handshake process, the client will send an ACK back. Once the server receives said ACK, the connection establishment process will be complete. A little more about TCP is that the three-way handshake, as I've already said, is extremely helpful for transferring data on a network, along with retransmission and error detections. Although all of these add to reliability of the data packets getting to their destination safe and sound, there is one major downfall. The downfall is these processes do lengthen latency, which lengthens the time it takes to get the packets where they need to be. So this is why, if there is a need for speed over dependability when transferring data, users will typically utilize the User Datagram Protocol, UDP. And this is how TCP holds up to UDP. TCP has its purpose, as we've talked about and as it's shown in the figure on the right. It is perfect for surfing the web, emailing, or any other basic everyday internet needs. Whereas UDP, as shown on the right, is used for a little more strenuous internet needs, such as music and video streaming, as well as online gaming, or any other internet needs that may occur that are a little more hefty as far as the data packets being transferred. UDP also offers a faster transfer of data, but without the reliability of the TCP transfer, whereas TCP offers a slower transfer, but with 100% reliability guarantee. So it just depends on what the user is needing at the time, which will determine which type of protocol will be used to transfer the data packets. This is how TCP compares to OSI, or Open System Interconnection. On the figure shown and on the right side, the OSI is more complex than the TCP model. The OSI has 7 layers, whereas the TCP only has 4. These two models do differ quite a lot, not only in the number of layers that they have. OSI uses a vertical approach. TCP uses a horizontal approach. OSI's transport layer guarantees transfer, but TCP transfer is still way more reliable. And even though TCP transfer does not guarantee the delivery of the data packets like OSI, it is still a reliable source to send data packets across a network. Both models' transport layers are different. OSI's connection-based is connection-based, TCP is connection-based and connectionless-based. OSI is a guideline to base a network around, whereas TCP is actually an implementation of the OSI model. OSI has a hard time fitting all of its protocols into its model, and TCP doesn't even follow any protocols at all, so TCP does not have that same problem as OSI. This is what TCP is used for. The main purpose of TCP is to offer a 100% secure path for transferring data. No matter what, no matter the size, it doesn't matter. It will 100% be secure and the data will reach its destination between a client and a server. So that is a major benefit of TCP, that no matter how large the data packet may be, it will always get to its destination safe and sound. And because TCP is so reliable, higher level protocols that require transmitted data will utilize TCP for transferring their data. Some of the high level protocols that utilize TCP are Secure Shell, or SSH, File Transfer Protocol, or FTP, or Post Office Protocol, POP. And the list could go on. These are just a few of the protocols that utilize TCP at the application layer. There's actually 3 or 4 more. I just didn't put them on here because they were so strenuous and lengthy, and these 3 are the main ones that utilize TCP at the application layer. This is the importance of TCP. TCP is most important because it sets a baseline for how all of the information on the internet should be communicated. It is actually the foundation of the internet. So without TCP, the internet would not function properly. So our entire world today as we know it would not be the same, because the internet wouldn't function properly, so we couldn't go and just look up anything we may need in the blink of an eye. Our entire world would be different without this protocol. TCP is utilized every day, as I was just saying, on the internet to ensure that all data transmissions, no matter what, are carried out properly. Because if they weren't carried out properly, the internet, as I said, wouldn't function properly. And since TCP is the foundation of the internet, everything it does is actually performed uniformly, so the same across the board no matter what. And TCP is extremely flexible and adaptable, making it another good reason to be the foundation of the internet. So any changes that are made or any new protocols that may be introduced, TCP can accommodate automatically to those changes. So no matter what, TCP can guarantee safe and secure packets of transfer.